here we're going to learn about the interior and exterior angles of polygons. So interior means they're on the inside, exterior means they're on the outside, and a polygon is just any closed shape with straight sides. If I say it's a regular polygon, that means all the sides are the same length, all the angles are the same measure. But if I just say it's a polygon, that just means it has straight sides and it doesn't have any openings in it. So that's really just a very general word for a shape with straight sides. So the interior angles are formed at each vertex of a polygon, inside the figure. So we have these equations that we're going to use to decide both the sum of the angles and each individual angle. Before we get to that equation, I just want to show you where this is coming from. We know that a triangle has 180 degrees on the inside angles. Those three we know are going to add up to 180. We know for a quadrilateral that they're going to add up to 360, but I just want to show how we can use this to show that for all of these, or really to show what the sum is going to be for all of them. So if I imagine drawing a triangle in this quadrilateral, I'm just going to split this into two separate triangles. It doesn't really matter which vertices I use. Well, let's say I choose to connect that one, creating two separate triangles. I have one there and one here. Well, I know the interior angles of each of those are 180. So that's 180 plus another 180. This angle, and this angle together are 180. This one, and this one together are also 180. And then I know that these two combine to make that angle in the quadrilateral, these two combine to make that one, and together those four angles make up the quadrilateral, which was just 180 plus 180, so that's got to be 360. For a pentagon, I'm going to do kind of the same thing. I'm going to split this. I'm going to draw a line from that vertex to that one, and then to this one, creating 1, 2, 3 triangles. 3 times the interior angles of 180 is 540. I'm going to keep that pattern going. I'm going to connect, let's say, these guys. I don't know why that split happens right in the middle of my smartboard. Those are supposed to be straight lines. I promise I'm drawing them straighter than that. 1, 2, 3, 4 triangles are created there. They each have a measure of 180 degrees, so that gives me 720 altogether. A heptagon is a 7-sided shape. I'm going to do the same kind of thing, connecting one vertex to each of the other vertices, creating 5 triangles in this case. That would be 5 times 180, or 900. So you can see really just the number of sides that you have, or number of vertices that you have, let's say that, minus 2 is the number of triangles that we can form. We have 2 triangles in that one. We started out with 4 sides. Here we start out with 5 sides. Minus 2 tells us that we can create 3 triangles. Here we start out with 6 sides. Minus 2 tells us that we can create 4 triangles. A heptagon, or I've also heard of septagon, is 7 sides minus 2. So we can create 5 triangles. That's how we can figure out the sum of all of these interior angles. The number of triangles that we can create times 180 is the sum of all those interior angles. So I want to write a general rule for this. Well, it's 180 times the number of triangles that we have. The number of triangles is the number of sides minus 2. So I'm going to actually start with that part. N minus 2. N is the number of sides. Take 2 away from that. That's the number of triangles that we can create. And if we multiply that by 180, that's the sum of all the interior angles in that shape. So that's just how I derive the equation. Hopefully you understood that. At a minimum, you just need to understand how to use it. So I'm thinking about really just plugging in the number of sides into this equation each time. 180 times the number of sides minus 2, so 4 minus 2, or 360. Some of this you're just going to memorize. Like if I see a quadrilateral, I know immediately that's 360 degrees. So you might not even need to plug into the formula, but it is helpful. 1, 2, 3, 4, 5, 6, 7 sides. So 180 times 7 minus 2, or 180 times 5 is 900 degrees. All right, on this one I have 1, 2, 3, 4, 5 sides. So 180 times 5 minus 2, or 180 times 3, or 540 degrees. All right, you could try the last three on your own there. All right, when we're dealing with exterior angles, we're talking about angles that are on the outside of the shape now. So if you extend any line segment, if you extend this line, you're creating an exterior angle. You can also go the other direction with it. So let's say we extend this line, CD, if we extend that, we're creating this exterior angle, which is a linear pair with that interior angle. You can also extend it the opposite direction, creating another linear pair, or really the same linear pair, in the other direction. Now angle 1 is created by that line being extended. That's also the linear pair with this angle on the inside of that hexagon. So you can go either direction, creating a linear pair, creating an exterior angle. Each exterior angle is a linear pair with the interior angle. So the sum of these exterior angles, actually I'm going to draw the picture of this to describe why this is true first. If I imagine this angle C moving down to this vertex, well, this line is just this line. And now I'm just going to sketch this ray that's creating angle C. I'm going to draw it straight across like that, so that's angle C. I'm going to actually do that with each of these vertex or vertices. Angle B is created from this ray and this ray. Well, I already started that. That line and that line are the same. And now I'm just going to kind of sketch where this other ray is coming out to create angle B. I guess that should have been lowercase. I'm going to do the same thing with angle A. I see that this line, which is this in my new picture, and this line, which is actually lined up directly with this one, create angle A. Now this one and this one are the same. And then angle F is really created from that ray that I just drew, and this second one that I'm drawing, cutting across, straight across on the bottom here. That creates F. And then E, you can kind of see it here. Actually, these are corresponding angles because these are parallel lines. This one just happens to be a regular shape, so we got nice parallel lines created here. But this line and this line, or this ray, help create angle E. So you can see when I put those 6 angles together, they combine to make a full circle. That is always going to be true. It doesn't matter how many angles we have. Those angles gradually get smaller and smaller as we add sides, but it will always add up to 360. That never changes. The exterior angles of any polygon always add up to 360. It doesn't matter how many sides we have. Here I have 1, 2, 3, 4, 5 sides. The sum of the exterior angles is 360. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. The sum is still 360. We're talking about all of them added together. Gradually they get smaller and smaller, but to start, they're always going to add up to the same amount. All right, now we're dealing with specifically regular polygons. The reason we're specifically dealing with those is because you can divide them up evenly. If I know that this is 9 sides, and altogether they're adding up to 360. If I do 360 divided by 9, that tells me what each of those angles are. If it's not regular, if they're not all the same, you can't divide them because they're not going to divide up evenly. But if it's a regular polygon, you can do that. So all the interior angles of a regular polygon are congruent, which is really what I just said in a different way. The exterior angles of a regular polygon are also congruent. So we're really just going to take what we found before about the sum and divide it by how many sides that we have. So the sum for interior angles was 180 times n minus 2, where n is the number of sides. Oops, that's 180. So 180 times n minus 2 divided by the number of sides that I have will tell me what each interior angle is. It's the total divided by the number of sides. Same thing for exterior. That one's a little bit easier because the exterior always add up to 360, and then we just divide by how many sides we have. All right, so we're going to find the measure of each exterior angle here. So I have 1, 2, 3, 4, 5, 6, 7, 8. Oh wait, it doesn't matter. We're talking about exterior angles. They're going to add up to 360. It will matter for the next part, but really the top part, it's just coming from the total. That's 360 divided by how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each angle on the outside is 36 degrees. I'm going to do number 3. 1, 2, 3, 4, 5, 6, 7, 8. 360 on top, 8 on the bottom. Each of these angles is 45 degrees. You can do the rest of those 6. All right, now we're trying to find the interior measure, or each measure of the interior angles on these regular polygons. So first I have to figure out the sum. So the sum is coming from that equation, 180 times n minus 2. Well, that's 180 times 1, 2, 3, 4, 5 minus 2, which is 180 times 3, or 540. So it's 540 altogether. And I have 5 sides, so I split it evenly among those 5 to find out that each interior angle is 108 degrees. I'm going to do one more of these. I have 1, 2, 3, 4, 5, 6, 7, 8 sides. That's going to be 180 times 8 minus 2, or 180 times 6, which equals 1,080. And now I have 8 sides, so I'm going to split it evenly among those 8 sides and find out that each of those angles is 135. Let's say you forget one of these parts. Let's say you forget how to find the sum of interior angles, but you know that the exterior angles are 360. Well, this is the same shape as what we did before. If you wanted to, you could do 360 divided by 8 to find out that the exterior angle was 45 degrees. The interior angle just forms a linear pair with that. So 180 minus the 45 that we know is also 135. There's multiple ways you can figure this out using the exterior or the interior angles, depending on what you remember. Alright, I'm going to do 2 of these problems on the back with you. We're working backwards now to find the number of sides, so we're given an angle, and we're working backwards to find that n in the equation. So we're told here that the sum of the interior angles is 900. To find the sum of the interior angles, I would do 180 times n minus 2. So they're saying that equals 900. So then we're going to solve that equation to find n. You could also just kind of guess and check on this if you wanted to. But I'm actually going to set up the equation and then solve that. You could distribute the 180. I'm just going to divide by 180 on both sides. That'll give you n minus 2 equals 5. And then we add the 2 to both sides, and we get the n, or the number of sides, is 7. Number 14 is saying the exterior angle is 72. I know to find each exterior angle, I just take 360 and divide by the number of sides. So 360 divided by n equals 72. To solve this, I would multiply both sides by n. That would give me 360 equals 72 times n, and then you divide both sides by that 72. So this one has 5 sides. All right, I'm actually going to do one more. I'm going to do number 17 with you. This says each interior angle is 120. So if I set up that equation that I wrote before, 180 times n minus 2 divided by the number of sides equals 120. That's each interior angle. I could solve that equation. I could also just guess and check and think about which one's going to give me 120. I'm not going to do that. I'm going to think about, well, if this is the interior angle, then the exterior angle is 60. It's just supplementary with that. So 360 divided by some number of sides equals 60. So that one has 6 sides.